So now we will look into how to determine the derivative of all the three inverse trigonometric functions we covered in learning outcome 1. So if you have, so the table below actually summarizes how to determine the derivative. If you have y equals to sine negative 1x, so the derivative will be 1 over set of 1 minus x squared and multiplied by the differentiation of the x, which is always 1. Next, when you have inverse of cosine negative 1x, this will be the derivative. So the difference between the sine and cosine inverse function's derivative is just the negative 1. So please pay attention to the difference. Next, if you have y equals to inverse tangent, the derivative would be 1 over 1 plus x squared multiplied by derivative of x, which is 1. So all these have x as the inverse of the function. So therefore, multiplying by inverse, a differentiation of x is 1. So all these three derivatives are actually multiplied by 1. So therefore, there's no need to write to multiply by 1. So next, we will look into differentiation of more complicated sine, cos, and tangent inverse functions. For example, if you need to differentiate sine negative 1 over x, so therefore, you follow the formula again. Inverse differentiation of inverse sine will be 1 over set of 1 minus x squared. So the new x here is negative 1 over x. So therefore, you substitute the x here with negative 1 over x. And then next, you need to differentiate your x. So therefore, you differentiate negative 1 over x here and multiply it with the inverse. So it's 1 over 1 minus 1 over x squared multiplied by differentiation of this, which is 1 over x squared. And then next, you can actually simplify it. Or you can even leave your answer in this point if the question did not ask you to simplify your answer. Next example, if you have a question that says differentiate ln of something. So recall back when you need to differentiate ln fx, it will be f prime x over fx. So f prime x here is differentiating this over this is your new fx. So now we need to differentiate this. So in order to differentiate this, we need to apply the inverse cosine derivative law. So therefore, differentiating 1 gives you a 0. Differentiating cos negative 1x, as we have learned in the first table of this learning outcome, is negative 1 over set of 1 minus x squared. In the next line, you're just simplifying the function, as in you're rewriting it in a whole function form. Next, you also have to recall back to apply product rule, quotient rule, which is related with our semester 2 differentiation. So say if you have a function, differentiate x squared with inverse cosine. So this one, it has two terms, u and v. So your u is x squared, your v is inverse cosine set x. So therefore, you can use the product rule here. Differentiating x squared gives you 2x. You copy the v plus copy the u, x squared, differentiate inverse cosine. So use the inverse cosine differentiation law. It will be negative 1 over 1 minus x, so x squared, so it becomes x, and then you're expected to differentiate the third x. This is differentiation of the third x, which is half x negative half. And the next line, you just combine and simplify. So the first part, you just copy down. The second part, x squared multiplied by x negative half using index law. 2 minus half will be 3 over 2. And the bottom is just rewrote again. Next, if you have a question that says differentiate inverse tangent of a function. So this is like in tangent negative 1, this is your x. So the original formula for differentiating tangent negative 1x says the final answer will be 1 over 1 plus x squared. So therefore, applying this law, the basic law, 1 over 1 plus x squared, this is your x, so it's 1 over 1 plus x squared, and then you're required to differentiate the x. So this is differentiating the x. And as you're aware, this is a quotient rule. You require quotient rule to differentiate u over v. So therefore, this part is 1 over 1 plus x squared. You copy it down here. And now you use quotient rule to actually differentiate this function. So differentiating the top gives you cos x. You copy the bottom, minus. You differentiate the bottom, will give you sin x. And you copy the top. And then you actually just pay attention, yeah, it is u prime v minus v prime u. So it's minus, when you have 1 minus cos x, when you differentiate this, it gives you negative, negative sin x, so it becomes minus positive sin x. So pay attention to this, and then v square, denominator square. So this is revision on quotient rule, yeah. And then the next step is you just simplify the whole top. So you expand this, becomes cos x minus cos square minus sin x minus sin square. And then you just continue using basic trigonometry and simplify this part of the equation. Please work it out on your own on this part. It's just an expansion of the top and expansion of the bottom and making the denominator as a linear. Please try to simplify on your own. If you have any questions regarding the simplification, you can post it on the Padlet link that I provide on Vision related to this lecture.